So let's do another example. Let's imagine that we have a frictionless surface with a mass on it. We call it big M. We have a little pulley right here, and we have a string running over the edge of a table to a little small mass, little m. And we want to know what's going to happen. Now, we actually would have done this experiment. This is one of the lab experiments that we were planning on doing in class. Had we been in person, we'd have an air track set up here so that the mass can move along, floating in the air above the track, and a little small mass pulling here, and we would time all the motion here. So we didn't get to do that. One of the lab exercises that you're doing, however, uses a simulation of this. And so one of the simulations you do does precisely this sort of thing. And so let's say for my example here, the mass is 2.37 kilograms, and the little mass is going to be 49.8 grams. Okay, so I want to know what happens. Well, gravity is going to pull down here. There's nothing pulling back, so this whole thing is going to start accelerating that way. And so that means I want to find what is that acceleration right there. Okay, so how do we do this? Same way we always do this, free body diagrams. So for the big M here, we have the normal force pushing up, we have the weight pulling down, we have the tension pulling this way. Now these two cancel each other, and so the net force is just tension. So that is going to be equal to MA. Now for the smaller object over here, mass M, we have mg pulling down, we have the tension pulling up. Now I'm saying this way is positive. In fact, I'm going to do my curved axis, so this way is positive right here. So it's accelerating this way. This one's accelerating like that. Okay, so it's accelerating downwards here. And so I'm going to say, okay, mg is in the positive direction, tension's in the negative direction, and so that's going to be equal to ma. Okay, so what do? We got two equations, two unknowns, tension and acceleration. Well, hey, this says tension's that. Why don't I just plug it into the other equation? So mg minus big MA equals little ma. So we can do a little bit of algebra here, okay? And with just a little bit of algebra, then we can say that A is going to be equal to mg divided by big M plus little m. Okay, and so A turns out to be equal to, given the things we got, we had that little m was 49.8 grams, so 49.8 grams times G, 9.81 meter per second squared, divided by, oh wait, I gave the other one in grams, so we got to make the units work out. So I said that big M was 2.37 kilograms. So this was 2.37 kilograms. So I got to convert that. That's 2,370 grams. So this would be 2,370 grams. So grams plus grams is grams. Grams divided by grams is unitless. So all the units cancel right there. And so the acceleration comes out to be 0.202 meter per second squared. Okay. I could have used 981 centimeter per second squared there, and then this would have come out as 20.2 centimeter per second squared. Either one is correct. It's just, however you want to write the thing. Okay. So let's say let's take another example. Same thing on a frictionless surface, big M, and then little m. And so now let's say that little m is 37.7 grams. And I let go, and I notice that it starts accelerating, and the acceleration is 0.447 meter per second squared, and I want to know what was big M. Okay. How do we figure this? Well, gosh, we have the same basic situation here. Same equation as before. Same thing that we had before was that the tension here is going to be MA, and for the other equation over here, mg minus tension equals little ma, and so we can say that mg minus big MA equals little ma, right? Okay, and so all we have to do is solve. Let's divide through both sides by a. So we get mg over a minus big M equals little m. And then we just do some algebra. Big M equals little m times 1 plus g over a. Okay. No, sorry. I got that wrong. It'd be g over a minus 1. Okay. And so we plug in all the numbers, and we find that this is 790 grams for big M. Okay. And technically it came out to be 789.7, so this would be 790 decimal to indicate it's 3 significant figures right there. Okay, so there we have 2 different examples using this mass, and 2 masses here on a frictionless table. And again, this example relates to the PHYS lab that you're going to be doing.